Hello and welcome to this tutorial. Today we are going to talk about the PCR tool. So this is a tool that you can download on my Patreon. This one explicitly is the PCR top, and that's also what we're going to discuss today. There will be, and there also is a version that is called PCR pop for the new pop operators, but because they are still in alpha, we're going to discuss the top version only. And yeah, so I just dropped it into a new project here. And PCR stands for point cloud rendering. So this is a geometry component that allows us to render point clouds. So let's start by setting up some point cloud and a rendering pipeline. We could start with just a noise point cloud. So I'm going to drop down a noise top. I will set it to be non-monochrome, the offset to be 0, and under the common page, I will change the pixel format to 32-bit float RGBA, such that the values can actually be negative and larger than 1 as well. In TouchDesigner, you can always have a preview at such a point cloud that is stored inside of a texture here by first clicking A or setting the viewer active while having a toggle selected. And then right-clicking in here and say View as Points, or also just by pressing V. And then you will get a preview of how that image looks as a point cloud. So again, if you use shortcuts, you can press V while hovering above this, or first you would select it, press A, and then V to see the texture as a point cloud. So here we just have some random or noise point cloud. We can change some parameters of the noise, for example, the harmonics. I will reduce those a little bit and increase the period such that we get a slightly more structured point cloud here. And yeah, you can, for example, see why I would have changed it to be non-monochrome, because if it's monochrome, the point cloud will only be one line here in space. But yeah, I will not go into further details on this, change this back to the texture it is. And then this is going to be our positional data. So if you look at the PCR top, you can link a position and a color top to define the positions and the color of the particles or the point cloud. So you can either do this by dragging top into this parameter, or simply by connecting it to this one and to the first input. And as you can see, this also disables the parameter because you can define only one of both. Okay, so we do have some point cloud set up here, but we don't see anything yet. Of course, because we only defined the geometry, but not a camera and a render component yet. So let's bring in a camera. We can either use the default camera here, but I will go to the palette and use the camera viewport maybe. And here we can already see that there's apparently a point cloud being rendered. I will kind of ignore this rendering though, and instead drop down a render top here. This one asks for a camera, because it is currently looking for camera 1, and our camera is called camera viewport. So let's link the camera viewport as the rendered top's camera. And then I will also connect an output here, such that I will activate the display of this output such that we can see it already being rendered in the background. I will then have another look at the camera viewport and go to the settings page and set its background color to black, because I don't like to see that alpha grid. And in the camera settings, I will reference as a panel component. So what I want to reference is the project component, the project level. And if you go here to the common page, you will see that it has a parent shortcut, which is project. And hence we can always reference this simply by writing parent.project as an expression in here. And then this has the correct camera panel reference, and I will also reference the respective render top that we're using. All this setup is a little hideous. I'm sure you have your own setup, and or maybe you have, and then you can kind of ignore this, but I will talk you through this in case you don't really have one. I also tend to set the project, so on the top level of TouchDesigner, I will set the project width to be monitors 0.width and respectively the height to monitors 0.height, such that the project will always be rendered at the maximum resolution my monitor supports. Yeah, and then maybe in the perform window, you could like turn off borders. That's something I would do. And in the panel of the project, I would also allow mouse UV buttons left, middle, and right to navigate this. And then last but not least, the render top also should render in the correct resolution because it's still rendering at 1280 by the 720. And we can now again just reference this parent.project.width to get the width of that parent component. And now we are set up with our camera, and I can go into perform mode and actually look around my point cloud, which is already being rendered. So yeah, now we can get into the PCR itself. So why are we doing this? Like there are other ways to render point cloud. You can use a geometry and the point sprite and instancing process. But my main motivation here came from rendering point clouds more efficiently initially. And then later I explored ways of rendering point clouds with interesting depth of field. So that's kind of how we ended up here. If you look at the PCR parameters, you will see that the top most parameter is a mode parameter. And you have two modes currently, either splats or pixel. And we will discuss both, but you should note that pixels are only supported for Windows, while splats are supported on Mac as well. Yeah, so what are splats? Well, basically, I'm rendering each point here as a small circle, and if I increase the splat scale, you will do nothing else but increase the circle size, as you can already see here. So this is basically a scaling, a uniform scale for each point. But the interesting thing, kind of why I build all this, is the option to have depth of field, or what I here call bokeh strength. In order to use this, I will reduce the splat scale to something smaller again, set a certain focus distance, and then increase the bokeh. And now let's let's find a focus distance, and then you can see how some of these points are in focus and others are not. And we can control how strongly these fade out of focus using the bokeh strength. And then what I'm actually doing here, I'm rendering those points as circles still, but circles with huge softness that fade out towards the edge. And by doing that and layering all those points on top of each other, you get this soft depth of field. So this is my strategy of rendering if you use splats. And then I can zoom through this point cloud and have a different part of it in focus. I can define how strong the bokeh is, and I can define the global alpha or opaqueness, maybe. And here's something you should notice for sure, is that if I have a lot of points that overlay each other, like here, and that are getting big, this is not really exactly how I anticipated to look like, but you can fix this by going to render top and then choosing the pixel format to be something that is not 8-bit only, but maybe 16 or 32-bit. And you will see that 16-bit already is sufficient to render this smoothly. I don't know if you hear this, but my computer is definitely spinning up the fans because it is rendering these, well, 65,000 points, but all like layered on top of each other. And it's not rendering them as single dots, but as these splats, as I call it. And that's also something you should notice if you render using the PCR tool and you use splats. The performance of this rendering strongly depends on the size of your splats. So if I were to increase the bokeh strength even further, and those points get bigger and bigger, overlay each other stronger and stronger, you see how my FPS drops down. So that's something you should definitely be aware of. And now you might definitely be able to hear my computer fan spinning. Um, But yeah, this is the basic idea of the PCR tool is to render a point cloud using together with depth of field. What else do we have as parameters here? We can fade the alpha with the focus, so how such that the points get dimmer if they are out of focus, and I can define the range in which this happens with this parameter down here. So for instance, now only those points that are exactly in focus or within 0.15 units will be lit up and they kind of fade out in that range. And I can control it with this parameter. That's just something I found interesting. Oh yeah, and then this scale alpha by distance is something that I built in to allow you to have a similar appearance of that point cloud independently of how far away of it you are, such that it doesn't. So now you see how it scales if I move away, and if I don't use scale by distance, you'll see how it just gets brighter and brighter because they overlay each other. So by having this parameter turned on, it will look more similar even if you go further away. Let's say that one. Yeah, and then there is a option to use a fixed focus plane. So let's go back to the option of using the bokeh strength and maybe increasing the alpha. And before we had, if we don't use the fixed focus plane, uh, points will be in focus or out of focus depending on how close to the object I am, to the points I am. So if I move my camera, this shifts, and also depending on, the perspective. But if I turn on use fixed focus plane instead, I can define a plane through space that will be in focus. So by default, if I don't use any translation here, that is the Z plane. So and then I can move this through space, this plane, either by translating it or by rotating it. And I just thought that this probably also allows for interesting effects. Um, yeah, I think that this is more or less everything I need to say about splats. Maybe I should also show, well, let's use a second noise here, which I will set to output the noise only and be monochrome, maybe also with a higher period and less harmonics, and just connect this noise to the second input to show you that you can also use colors while rendering this. So here's now the same point cloud, but as noise. Um, yeah, this is about what I want to say with respect to splats. Feel free to explore this, and maybe I'll also show some. I think what looks interesting as well with splats is if you don't have so many points, um, but strong alpha and strong bokeh, I think there can be some interesting, and then maybe not a fixed focus plane, some interesting effects if you go through this. Um, I do think this is quite lovely. Maybe if we also animate this noise a bit in time. I think this already looks quite dreamy, let's say it this way. Yeah, so that's basically what PCR is about in general, this depth of field, this bokeh. I think that's something that point clouds in TouchDesigner are missing most of the time, so that's what PCR is about. But now that I've talked about splats, I want to talk about the pixel mode as well, which is, as I said, supported for Windows only. So we can stick with the same point clouds, but I will go on to render these as pixels. Rendering using pixel mode goes a completely different way behind the scenes. So you can, of course, go in here and have a look at how I'm doing stuff, and you will find that there are some GLSL tops here behind the scenes, and that I'm actually generating an image before that is then used as with a very simple material here. And yeah, but you don't need to understand how this is done. It's using image atomic operators, and that's also the reason why it's working on Windows only, to render points very efficiently. So compared to splats, if you render using pixels, this is very efficiently, and I would also argue more efficiently than most other ways to render point clouds in TouchDesigner. So I could go ahead and make this point cloud very dense. I should then reduce the alpha quite a bit, I guess. But here you see I'm now rendering 4 million points as far as I can tell, and this takes 2.5 milliseconds. And this is, yeah, the rendering is now mainly done inside of the PCR top. So the rendering top itself takes 0.3 milliseconds, and the PCR takes 2.5 milliseconds, and I'm rendering 4 million particles. So I would say this is quite fast. I can probably also go higher and go to, let's say, 16 million particles. And I'm still at only 9 milliseconds. So on my laptop here, I'm still able to render this at 60 FPS. So this is basically where my initial inspiration came from to create PCR, is to create a rendering for point clouds that is really fast. Let's go back to a quite low resolution example here. So this is only 65,000 points, because obviously, as you can tell, yeah, I'm rendering a lot of particles, but I'm rendering them as individual pixels, and that doesn't really look too interesting in the first place. There are a lot of applications, I think, where this is interesting. For example, if you maybe think about a Fusarum system or something, maybe, yeah, in general, 2D applications where you render millions of particles, then this is also super fast. But I also wanted to include the option to render the particles with bokeh. And I'm solving this in the pixel mode by, instead of rendering each particle as an individual pixel, you can, I'm switching between particle and point here, but you can choose to use more than one point per particle. So for instance, now I'm rendering each particle, each point in my point cloud as 32 small pixels, and they are scattered around the center of that particle. So maybe I will get rid of the color for a second to get more specific, and maybe even reduce the number of points even more, and to display this once, make it very obvious I'm here, yeah, only rendering a handful of particles, and with very high alpha. And you can see that I'm now rendering a small sphere of points for each individual point. And then I'm scaling that sphere of that particle depending on the focus, like how much the particle is in focus. And if we're doing this with a lot of points, like here, and also render each point as a lot of pixels, so I don't know, like this. Okay, now I'm rendering each point as 1000 particles, and then I'm back at 30 FPS. That's maybe a little bit too ambitious, but 512 points still work decently fine. And then I can, again, define my bokeh strength and fly through my point cloud and see it come in and out of focus. And then the rest of these parameters basically work the same as with splats, such that I can define the alpha. I can say whether or not I want to scale the alpha with distance. So if I'd have I don't know, this point cloud, I want it to look similar if I zoom out. And if I don't scale alpha by distance, this would get brighter and brighter and smaller and smaller. So yeah, again, this is why that parameter exists. Um, and yeah, of course, the focus distance, something we can play with. And we can use the fixed focus plane as well if we are in pixel mode as well. Yeah, to and yeah, also the scaling alpha with focus. Yeah, and this is basically, I guess now I went through all the parameters the PCR tool has. Maybe I want to show you some other applications. I don't really have all that interesting point clouds on this machine, so let's see if I find one um, on my machine. Okay. So here is one point cloud that actually is a Gaussian splatting scan, but still has a lot of points and looks quite cool. Um, let's change some parameters. But here you have a bigger point cloud that actually is a 3D scan of reality. And now I can like zoom through that point cloud and get that focus effect. Yeah. Okay, and I think that is about everything I wanted to say in this tutorial. And I've already seen amazing works by some people using the PCR tools. Thank you for sharing them online and for tagging me such that I can see your works. It's so much fun to see what you're doing with them. And yeah, if you have any questions, let me know either on Instagram, Discord, or Patreon. Yeah, maybe one last thing to mention is since this is a geometry, you can use the um, X-form parameters as well and rotate, scale, translate the whole point cloud using those parameters. Just so you know. Okay, I think that's it. And yeah, see you all soon. Bye.